So here's another one of those rather complex looking derivatives that I got from using the chain rule. And this is the simplified answer that I'm given in the answers to this particular problem, number 23 on that CUDA worksheet. And I'd like to see if I can get from here to there. So I'm going to start by just rewriting my, my complex answer so that I can work down directly from it. So what I need to notice here is that I have a binomial. I have a binomial. I have, this is one term, then there's a plus sign, and here is the second term. This term here is a product of a couple terms. This term here is a product. So this is a binomial. And what I see in this binomial is I see that I have this 3x to the fifth plus 2 binomial in both pieces of it. So what I'm going to do is I am going to factor out the piece with the lowest exponent. So I'm going to factor out a 3x to the fifth plus 2 to the negative 1/2. And if I do that, I get, well, this piece right here, now that I factored out to the negative 1/2, becomes 3x to the fifth plus 2 to the first power. Because, again, if I have 3x to the fifth plus 2 to the first, and I was to multiply, was to distribute this, I would add the exponents, and I'd wind up with 3x to the fifth plus 2 to the 1/2. So again, this is a little bit of an algebra trick, but you should get used to it because it really makes things simplifying. It makes simplifying things easier to take out the term with the lowest exponent. So I have that, and again, now it's times 2 plus 2x minus 5 times 1/2. Then remember, we factored this out. So that's really like times 1, because we factored out this 3x to the fifth plus 2 to the negative 1/2, and times 15x to the fourth. And I'll put all of that in brackets, because this has to be able to distribute to that and to that. Well, one nice thing is that I noticed in my answer that I have 3x plus 5 plus 2, 3x to the fifth plus 2 to the 1/2 in the denominator. So I now have it ready to go into the denominator. So I'm just going to rewrite this again. So all I've done is I've put my 3x to the fifth plus 2 to the negative 1/2 in down here as a denominator. And I got rid of this 1, because I really just put it there to show how I was factoring it out. It's not really necessary to have in there. So I'm getting a little bit happier, except that I notice I have a 3-layer fraction, because I have this 1/2 is right there on the top layer, and I'm not allowed to have 3-layer fractions. And really, I'm never allowed to have 3-layer fractions. So if I want to get rid of a 1/2, I could multiply this entire numerator here by 2, as long as I also multiply the denominator by 2. I'm multiplying by 2 over 2 on the whole fraction here. So this 2 gets applied to this 2 here, and now I have 3x to the fifth plus 2 times 4, plus, here's my plus sign, 2x minus 5. Now this 2 times the 1/2 makes it 1, so that just becomes times 15x to the fourth. And now my denominator is 2 times 3x to the fifth plus 2 to the 1/2. And again, if I kind of take a peek at my answer, I can see that's the denominator that I wanted. So my denominator is in pretty good shape right now. I just need to figure out, well, how am I going to get this numerator here to look like that numerator there? So let's take a look. What can I do? Well, I think I can do a little bit of distributing here. I can distribute this 4 to those two terms, and that would give me 12x to the 5th plus 8, plus, let's distribute this 15x to the 4th to these two terms, and that would give me 30x to the 5th minus 75x to the 4th, all divided by 2, 3x to the 5th plus 2 to the 1/2. And now I have like terms, this to the 5th and that to the 5th, and I get 42x to the 5th minus 75x to the 4th plus 8 divided by 2 times 3x to the 5th plus 2 to the 1/2, which is the simplification that they had, except that they're doing it wrong because I would like it in standard form and to switch those two few places. But otherwise they have it pretty good. So again, it's just some algebra stuff. Don't say you could never do this, because it's not true. You could do this, and the issue is really just kind of giving it a try. And this one trick here, way back in the beginning, of factoring out the common term with the lowest exponent, because then that's going to put it in the denominator for us, that is really like one of the key algebra tricks right here.